Hello, today we will see how alcohols act as electrophiles. Look at the diagram. The CO bond in the alcohol will break. For the hydrogen ion attacks XAC and the CO bond permeable breaks. Men and alkyl halide. Hello friends, today we will study the reaction of alcohols with hydrogen halides. Do you know reaction of ROH gives RS zinc chloride hydride as cation? For example, ethanol plus HCl greater than secondary greater than primary. Hello students, today we are studying the Lucas test. Look at the diagram. For quaternary alcohols, turbidity forms within 5 minutes. And for tertiary alcohols, turbidity is immediate. Hello, today we will discuss electrophilic aromatic substitution reactions of phenols. First, look at the resonance in the phenoxide ion. These structures show negative charge highly reactive with electrophiles. Dehydration is the removal of water from molecule. Here, ethanol reacts to form ethene and water. The hydroxyl group is removed as water, forming a double bond. Hello friends, today we study dehydration of alcohols. Ethanol gives ethene, procone gives propane, 2-ol gives 2-nipropane. Notice trend, tertiary alcohols degrade easiest, then secondary, then primary. Any questions? Find the major product for this reaction. We have butanol 2-ol reacting with acid. The OH group is protonated. Water leaves, a double bond forms. Okay, let's look at this mechanism. First, the alcohol is protonated by the acid. Then water leaves, forming a primary carbocation. This is followed by a hydride shift, creating the most stable tertiary carbocation ion. Find the major product for the following reaction. First, the alcohol is protonated by the acid. This forms an unstable oxonium ion. Then water leaves, creating a carbocation ion. Hello friends, today we will see the Sadzeff rule. See this reaction? The more substituted alkene is the major product. This is but-2-ene, the provided product, mass stay purple, and this is but-1-ene, the minor product. The major product is 1-methyl cyclohexene. The mechanism starts with protonation of the alcohol. This is followed by loss of water, forming a carbocation. Finally, deprotonation yields the alkene. Hello, today we will study the dehydration of 1-methyl cyclohexanol. The reaction proceeds via an unstable carbocation intermediate. The Sadzeff rule predicted 1-methyl cyclohexane. Find the major product for the following reaction. We have an alcohol reacting with acid. First, the OH group is protonated. Then water leaves, forming a carbocation. Hello everyone, let's understand the oxidation of alcohols very slowly. Primary alcohols have winning R group or Y1. Next, secondary alcohols have hydrogens and 2 R groups and no hydrogens. Today, we will learn about the oxidation of alcohols. Look at the diagram. We have primary, secondary and tertiary alcohols. For primary alcohols, the carbon has 1 R group and 2 hydrogens. Hello everyone, today it starts the oxidation of primary alcohols. Costly primer on aldehyde went to carboxylic. The agents are acidified KMnO4 or toward 503 Kelvin, it stops at the aldehyde. Hello everyone, today we will see the oxidation of primary alcohols. The best reagent is PCC, which stands for pyridium chlorochromate. PCC is formed from chromium trioxide, pyridine and hydrogen chloride. Thank you. Hello. Today we will learn about oxidation of secondary alcohols. The general reaction is secondary alcohol to ketone. The condition are COA3 in anhydrous medium or Cu at 573 Kelvin. Tertiary alcohols do not undergo oxidation. With acidified potassium permanganate, we see cleavage of the carbon-carbon bond, and with copper at 573 Kelvin, so no oxidation for tertiary alcohols. Hello, today we will see the reaction of a tertiary alcohol with acidified potassium permanganate. The pen shows the breaking bond. This is the key step in the mechanism. Hello. Today we'll see the reaction of a tertiary alcohol with copper at 573 Kelvin. These contain alcohol dipio homologous stereo-auto-1 alkene. The structure changes as you can see here. We will now look at the Lucas test for distinguishing primary, secondary and tertiary alcohols. Next, the reaction with phosphorus trihalides. And finally, in yeast, it is tertiary and secondary than primary alcohols.